Hi guys! In this video we're going to talk about the order of operations and evaluating expressions. And we're going to be working on the I can statement, I can use the order of operations to evaluate expressions. And this is going to be useful later on down the line when we are working more with algebraic expressions. So here's the order of operations again as a quick reminder. First you do parentheses or anything in grouping symbols to include absolute value symbols or brackets, or as we'll talk about later on, operations in the numerator and operations in the denominator. Followed by exponents, then multiplication and division from left to right, and addition and subtraction from left to right. And the mnemonic device we use is please excuse my dear Aunt Sally, where the first letter of each word represents a part of the order of operations. Parentheses, exponents, multiplication and division, addition and subtraction. If we wanted to evaluate these using the order of operations, I would simply have to start by saying, okay, do I have any parentheses? So looking at number 1, we don't have parentheses. Or exponents. But we do have multiplication, so we would multiply 4 times 5, and that would give us 20. Sorry, my pen wasn't working very well for a second there. And 3 plus 20 is 23. For number 2, I have no parentheses, but I do have exponents. So I need to do 2 times 2 first, which is 4, and then I can multiply that by 3 to get 12. In number 3, I need to do what's in the parentheses first. 3 plus 2 is 5. And 3 plus 4 is 7. Now I can multiply 5 times 7 to get 35. And in number 4, I need to do the order of operations, meaning I need to do parentheses first, so 10 minus 7 is 3. And then I'm going to bring down what I have here, left over. Next I would add or subtract left to right, because there's no multiplication or division or exponents. And I add or subtract whichever comes first, left to right. So 25 minus 3 is 22, and 22 plus 8 gives me 30. Notice I had to subtract first because that came first in my expression. Operations in the numerator or denominator are to be treated as if they were in parentheses. And this was an area on the last test that a couple of you mixed up. So let's look at this problem. If I have 2 times 3 squared over 15 divided by 3 plus 1, before I could go and do the division, which the fraction bar would indicate, I need to do what's in the numerator and evaluate that, then evaluate what's in the denominator. This means that I will be adding this 1 before I end up doing the division that the fraction bar indicates I should do. So I would start by evaluating the numerator. I have to take care of the exponents first. So 3 squared is 9. So I have 2 times 9 over 15 divided by 3 plus 1. I have not completely evaluated my numerator, so I need to do that now. 2 times 9 is 18, and that's all over 15 divided by 3 plus 1. Now I can go through and evaluate my denominator. 15 divided by 3, because division comes before addition, is 5. And 5 plus 1 is 6. So now I can do my division. And I know that 18 divided by 6 equals 3. So when you have a problem like this, it might look scary and difficult, but really, it's just 2 problems using the order of operations. A problem in the numerator and a problem in the denominator. And when you're done, you divide your numerator by your denominator. Now it's your turn. Pause the video and complete these 5 problems. 1, 2, 3, 4, 5. When you finish with these in the work section of your WSQ, hit play again because we're going to talk about evaluating expressions, and you're going to see it's very similar to using the order of operations with one little extra step. Now let's talk about evaluating expressions. First of all, an expression is made up of one or more terms. And a term is a number, variable, or the product of a number and variables. So let's look at some examples. If my expression is 12, there's one term because there's only one number there. If my expression is n, there's only one term because there's only one value or one number there. However, if I had n plus 12, since n and 12 are being separated by an addition sign, they're each their own term. So this expression has 2 terms. 3n plus 12, now remember, product of a number and variables represent one term. So 3n is a term and 12 is a term. So any number, variable, or product of a number and variable that comes between addition or subtraction signs represent a term. 3n plus 12m has 2 terms, 3n and 12m. 3n plus 12m plus 25 has 3 terms because there are 3 things, numbers, variables, or product of numbers and variables between addition or subtraction symbols. 12 plus nm plus 25 has 3 terms because there are 3 things that come between the addition or subtraction symbols. A coefficient is a number that is used to multiply a variable. So in the expression 7n, 7 is the coefficient because it's being multiplied by the variable. In 3m, 3 is the coefficient. In 12x, 12 is the coefficient. So it's any number that's being multiplied by a variable. In 9y, 9 is the coefficient, and in 10z, 10 is the coefficient. Here I have an algebraic expression, 5 plus n. It's an algebraic expression because it has at least one variable. In this algebraic expression, I have the number 5, which is not a coefficient because it's not being multiplied by n. It's being added. And if I have a number that's being added or subtracted to or from the variable, it's called the constant. It's not going to change. However, a variable can change values. It can have many values. 5 plus n is called an algebraic expression because there's no equal sign and the expression has a variable. We don't know how much this is worth because we don't know what n is worth. If n was worth 1, then I would substitute it into the expression and get 1 plus 5 to find the final value of 6. If n is worth 2, I would substitute it in. Where I see n, I'd put a 2 and get 2 plus 5, which is 7. If n was worth 3, I would plug 3 in where I see an n and add to get 8. So n is called a variable, once again, because it can change or vary. It can have many values. 5 is called the constant because no matter what I change the variable to, that 5 stays the same. Now it's your turn. You're going to evaluate these expressions. You first need to substitute the values that are given for A, B, or C. Let's do number 1 together. If I wanted to evaluate this expression, I would plug in for A a 2. And since 2 and A are right next to each other with no operation in between, I know I need to multiply those. In the second part, I'm going to take 2 times b, and in this case, b is 3. Now I just use the order of operations to evaluate this expression. Since there's no operations to perform within the parentheses, and there are no exponents, I move on to multiplication. 2 times 2 is 4, and 2 times 3 is 6. Now I can add 4 plus 6 to get 10. In the work section of your WSQ, complete numbers 2 through 5. You can go back and watch any portion of this video as many times as you need to, or the whole thing. But don't forget to WSQ in your notes.